Hey everyone! Welcome back to NextED, the tech education series by Nexaspaces. You're watching Module 5, IoT Communication and Networking, and this is Part 1, What is IoT? Before we dive into communication protocols like Wi-Fi or MQTT, we need a solid foundation. What exactly is IoT? What are its building blocks, and how does it all work together? In this video, we'll decode the core concepts of IoT, its architecture, components, categories, how data flows, real-world use cases, and even the challenges engineers face. Let's get started. The Internet of Things, or simply IoT, refers to the growing network of physical devices around the world that are connected to the Internet and to each other. These devices can collect data, process it, and perform actions, all with minimal human intervention. Picture this: a smartwatch that tracks your heart rate, a smart fridge that tells you when groceries are low, or an irrigation system that waters your plants only when the soil is dry. These are all IoT systems in action. At the core, IoT is about bridging the gap between the physical and digital worlds, letting machines sense, think, and act. It's not just smart homes, it's smart cities, smart farms, smart hospitals, and even smart factories. It's about intelligence at every layer of life. An IoT system is made up of 5 fundamental components. Let's walk through them. First, sensors and actuators. These are the eyes, ears, and limbs of your system. Sensors collect data from the environment, like temperature, motion, humidity, light, or gas levels. Actuators, on the other hand, do something in response: turn on a fan, open a valve, blink an LED. Second, embedded devices. This is where microcontrollers like the Arduino Uno or ESP32 come in. These boards process sensor data and decide what action to take. They may also send this data to the cloud for more complex processing. Third, communication protocols. Data needs a road to travel. Protocols like Wi-Fi, Zigbee, Bluetooth, and LoRa enable this. Some offer long range, others are optimized for low power or speed. Each has its place, and we'll explore them deeply in future videos. Fourth, cloud infrastructure. Once the data is transmitted, it's usually stored and analyzed in the cloud using platforms like AWS IoT Core, Google Cloud, or Azure IoT. Here, decisions can be made using artificial intelligence or machine learning. And finally, the user interface. This is where humans interact. It could be a mobile app, a dashboard, or even a voice assistant like Alexa. The UI allows us to control the devices or get alerts and visualizations. IoT devices can be grouped based on where and how they're used. Broadly, there are 3 major categories. 1. Consumer IoT. These are the smart devices we use at home or in our personal life. Think smart speakers, fitness bands, or smart thermostats. 2. Industrial IoT, or IIoT. This is used in factories, manufacturing plants, logistics, and agriculture. Here, IoT enables machine health monitoring, predictive maintenance, and real-time alerts. 3. Enterprise IoT. Think about smart buildings, connected offices, or energy-efficient corporate campuses. Sensors monitor everything from temperature to motion to light usage, helping optimize resources. Now that we understand the components, how do they come together? Let's look at the typical architecture of an IoT system, which can be divided into several layers. 1. Perception layer. This is the physical layer. It includes sensors, actuators, and embedded devices that perceive the environment. 2. Network layer. This is the communication layer. It transmits the data to the cloud or processing units via various protocols. 3. Processing layer. This could be the microcontroller or a local server, edge device, or even the cloud. It analyzes data and makes decisions. 4. Application layer. This is what the end user sees: dashboards, alerts, controls. 5. Business layer, optional, used in advanced systems to apply analytics and rules for decision making, often integrated with enterprise systems like ERP or CRM. Let's understand the actual data flow in an IoT system using a real-life example. Imagine a smart farm. A soil moisture sensor detects that the soil is dry. That signal is read by an ESP32 microcontroller. The ESP32 sends this data using Wi-Fi to a cloud server. The cloud system processes it and decides, time to water the plants. It sends a signal back to an actuator, turning on the water pump. This data loop, from sensing, to processing, to action, is what makes IoT smart. Now let's talk about where the thinking happens in IoT. There are two major approaches. Edge computing: here, data is processed right where it's generated, at the edge of the network. This reduces latency and saves bandwidth. For example, a security camera can detect motion locally without sending all footage to the cloud. Cloud computing: in this case, data is sent to centralized servers in the cloud where more advanced processing or AI can take place. It's great for deep analytics, visualization, and large-scale decision-making. Modern systems often use a hybrid approach. Critical decisions are made at the edge, while trends and analysis happen in the cloud. Despite its amazing potential, IoT faces many challenges. 1. Security: devices are often vulnerable to hacking. Encrypting data and updating firmware regularly is essential. 2. Scalability: managing hundreds or millions of devices requires smart architecture. 3. Interoperability: devices from different manufacturers must work together smoothly. Standards like MQTT and CoAP help, but there's still work to be done. 4. Power management: many IoT devices are battery operated. Optimizing for low power is key, especially for remote sensors. Overcoming these challenges is what makes IoT engineering such an exciting field. IoT is already transforming the world around us. In smart cities, traffic sensors help reduce congestion and improve emergency response. In agriculture, IoT enables precision farming with soil monitoring and climate data. In healthcare, wearable devices help doctors monitor patients remotely. In industry, predictive maintenance prevents machine breakdowns and reduces costs. The future? Even smarter systems with real-time AI decisions, self-healing networks, and massive-scale automation. To summarize, IoT is the backbone of our smart future. In this video, we broke down what IoT is, its core components, layered architecture, and how data flows through the system. In the next video, we'll start diving into communication protocols, like Wi-Fi, Bluetooth, Zigbee, and LoRa, and understand how they enable devices to talk to each other. So make sure to like, subscribe, and hit the notification bell. You're watching NextED, powered by Nexaspaces, building the tech minds of tomorrow.